In the early 1940s, as the war in the Pacific shifted into island-by-island fighting, the Imperial Japanese Army adopted a deep defense approach. Fortifications, bunkers and networks of trenches were cut into volcanic rock, offering limited fields of view but providing survivability for those inside. These strongpoints were designed to withstand naval gunfire, artillery, and normal tank fire. For Allied assault forces, especially the U.S. Marine Corps, a new problem emerged: how to defeat stubborn defensive positions that ordinary infantry could not easily reach without suffering heavy casualties. Part of the answer came from a weapon that already existed but had limited effectiveness: the man-portable flamethrower. In the Pacific theater, the M1 system and its M1A1 variant became, in theory, an effective tool for clearing fortifications. The flame could melt materials, burn and asphyxiate defenders sheltered in bunkers. Combat experience, however, demonstrated deadly limitations: short range, small fuel load, wartime reports typically cite about 4 to 5 gallons, and most importantly, the operator had to approach relatively close to the target, making them a prime target for enemy gunners. Wartime figures and numerous after-action reports show that flamethrower teams often suffered very high casualties. In many battles, using a man-portable flamethrower meant accepting extremely high risk of death to open the way for comrades. The problem for commanding officers was clear. If the destructive power of flame was undeniable for eliminating fortifications, could that flame be mounted on an armored vehicle to protect the operator and increase range, fuel capacity, and durability in combat? That apparently simple idea set off a series of experiments and developments to turn tanks into mobile flamethrowers. The first experimental and improvised steps appeared in places like Bougainville and New Guinea, where soldiers and repair crews improvised in response to battlefield needs. Maintenance and engineering units removed the bow machine gun from some light M3 Stuart tanks and installed Ronson flame units, a system popular in Canada and the United States for personal and small-scale applications. These early homemade conversions stored fuel in the emptied ammunition stowage. Their chief feature was increased range and the ability for the crew to operate from within armored protection. Results were quickly noted. A modified M3 Stuart could approach a target and project flame far more effectively than a team of man-portable flamethrower troops, while protecting its crew from small arms fire. Field reports from Bougainville, late January 1944, and subsequent engagements showed a clear pattern. When the flame tank appeared, defensive emplacements were neutralized quickly and attacker casualties fell noticeably. This reality attracted commanders' attention and spurred efforts to formalize a flamethrower tank program. In records, some local commanders reported directly on the need for mechanized flame equipment to replace the extremely hazardous role of individual flamethrower troops. Those reports, when passed up the chain to higher commanders, paved the way for a more systematic research and development program. The next important turning point came when the Chemical Warfare Service and technical research teams were tasked with designing a flamethrower system suitable for the M4 Sherman chassis, the Allies' standard medium tank. The work was not merely attaching a nozzle to a hull. To become a useful battlefield weapon, the system had to meet very strict requirements: much larger fuel capacity, sufficient range to reach beyond the effective engagement zones of enemy infantry weapons, the ability to spray continuously long enough to affect extensive bunker networks, and crucially, the need to disguise the system so it could not be singled out and destroyed by concentrated enemy fire. Running in parallel with the mechanical work was a fuels revolution: napalm. The napalm compound, developed in the 1940s by chemist Louis F. Pfizer and his team, is a gasoline thickener that turns volatile fuel into a sticky gel that burns longer and at much higher temperatures. Napalm overcame a fundamental weakness of liquid gasoline. Sprayed gasoline tends to atomize into a mist that disperses and burns unpredictably. Napalm sticks to surfaces, continues burning, and generates extreme heat, and it easily penetrates vents and cracks in fortifications. The advent of napalm significantly increased the tactical penetrative power of mechanized flame systems. Designers had to run extensive tests to find the optimal formulation, thick enough to adhere, yet stable enough to burn reliably under operational conditions. The result was systems configured for the Pacific Theater to carry hundreds of gallons of napalm fuel and to spray at high pressure, giving effective ranges far greater than man-portable weapons. To preserve surprise, many designs concealed flamethrower components inside dummy gun barrels or arranged them so that from a distance the Sherman still looked like a standard tank, forcing the enemy to hesitate and reducing the likelihood of concentrated counterfire against the flame tanks. Organizationally, dedicated flamethrower tank units were formed and trained for the mission. Crews had to understand the technical operation of the flamethrower system, coordinate with infantry to form tight assault formations, and adapt operational procedures compared with ordinary tanks. Crews learned to fire in turns to maintain fuel pressure, withdraw to reload when necessary, and work with standard Shermans to provide cover and clear the way. Tactics were transformed. Flame projection ceased to be an ad hoc individual action and became a heavy tactical element in bunker busting. Operations field trials on Saipan in mid-1944 were the first large-scale demonstration of the tactical consequences. Shermans equipped with flamethrower systems, some early documents nicknamed prototypes Satan or similar, proved particularly effective at breaking up defensive clusters that had been built on the assumption the enemy possessed only man-portable flamethrowers, i.e., weapons that required close approach. Reports indicated that by projecting flame from a safe distance relative to infantry teams, tanks forced bunker occupants to choose between staying and being burned or abandoning their positions. The psychological impact of mechanized flame was as significant as its physical effect. It shook confidence in the supposed impregnability of fixed defenses. All these developments, from improvised M3 Stuart conversions to research at Schofield Barracks, from the adoption of napalm to the standardization of flamethrower systems on the M4 Sherman chassis, were part of a process, transforming a simple tactical idea into a systemic battlefield technology with corresponding production scale, organizational structures, and combat doctrine. The next section will detail the first deployments of flamethrower tanks on large battlefields, such as Iwo Jima and Okinawa, how they affected Japanese defensive morale and tactics, and the military as well as humanitarian consequences that followed. When the mechanized flamethrower systems were refined and standardized, the next step was to put them into combat on real battlefields, places where Japanese defensive constructions revealed their true depth and complexity. Deployment was not a single set of actions, but a continuous process of adaptation. Engineering improved, tactics changed, and the psychological reactions and countermeasures of the defender evolved too, often too late or not effectively enough. The Battle of Saipan in mid-1944 was one of the earliest large-scale tests involving flame tanks. There, converted light tanks and some Shermans fitted with flame assemblies produced unexpectedly effective results. They could spray gelled fuel into vents, doorways, and observation slits of hardened positions, turning bunkers from shelters into furnaces. The effects were twofold: physical, destroying or neutralizing the combat effectiveness of defenders, and psychological, undermining will to resist. Attacking reports quickly noted that emplacements were neutralized faster, attacker casualties fell, and the integration of flame tanks into operations against fixed defenses became a priority. Iwo Jima, February-March 1945, was a turning point. The Japanese had dug extensive cave and tunnel systems into the volcanic rock, creating tightly controlled multi-layered defenses. Here, Shermans equipped with flamethrower systems, variants under the PACW program, proved their purpose: to project flame into caves, deny them as hiding places, and expose tunnel networks by forcing heat, smoke, and fire inward. Tactically, flame tanks reduced the number of direct approaches infantry had to make, combining standoff firepower with the mechanical application of flame. From the defensive perspective, Japanese commanders discovered a grave vulnerability. Escape routes and observation slits were no longer safe if fire could penetrate deep into the system. The Battle of Okinawa, April-June 1945, was the climax, where flamethrower units were deployed more widely and systematically. U.S. forces formed dedicated units, trained crews in standardized procedures, and organized large-scale napalm logistics and maintenance. Combat on the Shuri Line, Sugarloaf Hill, and around Shuri Castle demonstrated how flame tanks changed the tempo of battle. Rather than a simple infantry assault, attacks often began with targeted bursts of flame to neutralize the defense line, followed by standard tanks and infantry to clear and advance. Flamethrowing could be rotated among vehicles to maintain continuous pressure on underground structures, something man-portable flamethrowers could not provide. Tactics evolved quickly. Single flame tanks were vulnerable to concentrated enemy fire. U.S. forces learned that operating in pairs or groups, coordinated with standard tanks and infantry on the flanks, reduced the risk of being destroyed by anti-tank traps, mines, and small anti-tank guns. They employed reconnaissance by fire, short bursts to observe smoke from vents, locate hides, then deliver heavier bursts, a method both effective and brutal. Command skills, control of fuel pressure, rotating vehicles to resupply and depressurize, and timely coordination with infantry became vital survivability factors. On the Japanese side, initial responses were more cognitive and psychological than technical. Doctrine and warrior ideals, Bushido, the spirit of self-sacrifice, made many commanders reluctant to acknowledge the effectiveness of the new weapon, since to admit it was to concede a failure of traditional combat methods. Reports reached some central headquarters, but official recognition and large-scale adjustments were politically and culturally difficult to accept. Experimental countermeasures, adding more exits, building double compartments, using water or non-flammable materials, were often ineffective against napalm, which stuck and burned long. Ventilation sometimes accelerated the fire, and the volcanic rock construction made conventional firefighting nearly impossible. The psychological impact on Japanese soldiers was clear. Mechanized flame removed the option of an honorable, visible death before the enemy. Death became anonymous, horrific, and devoid of warrior ritual. This caused a breakdown of morale in some units, leading to unauthorized withdrawals, abandonment of positions, or surrender in isolated cases, phenomena previously rare in Japanese military tradition. The effect was not easily quantified materially, but had strategic consequences. Psychological instability reduced collective defensive effectiveness. Crews of flame tanks also faced intense psychological pressure. They witnessed directly the gruesome results of the weapon they operated, the cries, the burning bodies, and the sheer brutality of the act. Post-war reports and records note elevated rates of psychological disorder, traumatic obsession, and PTSD symptoms among these crews compared with standard tank crews. These sources highlight an enduring ethical question. Does tactical effectiveness justify the psychological harm to operators and the humanitarian horror inflicted? Strategically, flame tanks proved to be a weapon that could reduce attacker casualties compared with alternatives such as direct infantry assaults on fortifications. Many U.S. commanders judged that mechanizing flame limited friendly losses and shortened the time needed to seize positions. However, that effectiveness carried moral and political costs. Napalm and its use to burn people drew heavy criticism during and after the war as observers more fully understood the impact on civilians, the environment, and norms of warfare. Logistically, supplying napalm, pumps, piping, and maintenance for flame units required stable supply lines. That is why only a fraction of Shermans were converted to flamethrower variants rather than the entire force. Conversions had to balance overall firepower needs against the specialized mission. Dedicated units were formed and trained at bases such as Schofield Barracks, and large-scale supply arrangements were organized to sustain operations. When the war ended, the legacy of flame tanks was recorded from multiple perspectives. Technically and tactically, they inaugurated a chapter in combining chemical, flammable technologies with heavy mechanization, setting precedents for later specialized weapon systems. Humanitarianly and politically, the brutality of napalm and its employment raised questions about the limits of warfare and the need to adapt rules of armed conflict. In later conflicts, although some forces studied and used flamethrower systems in specific contexts, political pressure and ethical concerns reduced their prevalence in modern warfare. When examining the consequences of mechanizing flame on the Pacific battlefields, it is necessary to distinguish three layers of impact. 1. The immediate military effectiveness on the battlefield. 2. The casualties and psychological burden on both attacker and defender. And 3. The long-term strategic, ethical, and policy consequences after the war. Figures, unit reports, and witness testimony paint a mixed picture. From a strictly tactical standpoint, the flamethrower systems on Shermans were transformative tools. But from humanitarian and policy perspectives, they left deeply contested legacies. On tactical effectiveness and campaign statistics, the operational records of flamethrower units, especially the 713th Flame Tank Battalion on Okinawa, show considerable destructive power. In campaigns from Iwo Jima to Okinawa, flame tanks were used to neutralize cave, cavern, and hardened fortification systems that standard weapons could not or would not quickly destroy. On Okinawa, campaign records include hundreds of thousands of gallons of napalm fuel expended. Campaign totals reported in some accounts reach roughly 200,000 gallons. Thousands of defensive positions neutralized, and according to 713th Unit records, reports confirming thousands of Japanese casualties directly attributable to flame tank operations in their areas of action. U.S. commanders judged that the use of flame tanks reduced infantry casualties in many situations where otherwise American forces would have had to make direct assaults with very high loss rates. Numbers cited by witnesses in wartime reports make stark comparisons. Some military documents and post-war analyses estimated that flame tanks may have saved tens of thousands of American lives that would otherwise have been lost in replacement infantry assaults. A commonly quoted post-war estimate appearing in minutes, and some studies ranges around 50,000, 100,000 U.S. servicemen spared due to the use of this weapon in bunker-busting operations. Exchange ratio figures in a few campaign analyses are cited as very high. Methodologies vary by scope, but internal reports sometimes record very high Japanese to American casualty ratios during instances of mechanized napalm use against fixed positions. Additionally, tank loss records show a material cost. On Okinawa, dozens of tanks were at times destroyed or heavily damaged in clashes and anti-tank traps, indicating that the flamethrower was not a magic weapon and had to be employed with caution and in coordination. On the human side, the psychological effects were deep and complex. For Japanese soldiers driven into caves, napalm and mechanized streams of flame removed the option of a glorious fight in the Bushido sense. Death became anonymous, painful, and devoid of ritual. Many POW and witness statements after the war describe panic, abandonment of positions, and the breakdown of discipline in some units when faced with the prospect of being burned in place. These developments, though partly subjective psychological phenomena, indeed degraded the defensive effectiveness of fortifications that relied on willful resistance. Conversely, flamethrower tank crews themselves regularly confronted the direct consequences of their actions. Hearing cries, witnessing victims, and operating a weapon that inflicted agonizing injuries on others. Medical records and post-war studies record higher rates of post-traumatic stress disorder, PTSD, among flamethrower crews. Compared with standard tank crews, the reference figures in some later analyses show roughly a 40% increase in psychologically related symptoms. This evidence underscores that military victory can carry a large psychological debt. Ethically and legally, flamethrowers and napalm became subjects of debate after the war. During wartime, napalm was developed and employed with a clear utilitarian rationale to destroy fortifications and protect assaulting troops. After the war, as societies began to scrutinize the consequences for civilians and the environment, napalm became emblematic of industrialized warfare's brutality, scorched landscapes, charred bodies, and long-term environmental effects. Debates about the legality and morality of creating and using incendiary weapons spread through military, political, and academic forums, contributing to later restrictions on certain uses of incendiary weapons. At the international law level, while there was no absolute ban on all incendiary weapons at the time, subsequent conventions and evolving public opinion altered the framework governing the use of weapons that cause widespread or indiscriminate harm. Practical policy consequences also emerged. The U.S. military recognized that mechanized flame was an important operational tool against island-type fortified defenses, so doctrines and training continued to develop. For example, manuals and specialist doctrine on flame warfare were compiled in the 1950s. At the same time, the politics and public opinion surrounding napalm, especially where civilians were affected, helped change later deployment patterns. Napalm use in the Vietnam War provoked global outrage, and political pressure ultimately led to tighter controls over its application, and in some contexts, its removal from routine tactical inventories. From a lessons learned perspective, a few conclusions are clear. First, technological innovation can fundamentally shift the balance between attack and defense. Second, military effectiveness cannot be separated from ethical consequences and psychological costs for both perpetrators and victims. Third, adopting a technology to save soldiers' lives must be weighed against humanitarian considerations and long-term effects on civilians and international relations. These lessons explain why modern weapon design and policy increasingly place legal, ethical, and public relations considerations alongside pure tactical effectiveness. Looking back at the history of flamethrower tanks in the Pacific, it is important to distinguish between two dimensions of impact. On one hand, their direct battlefield legacy, how they altered the sequence of actions leading to the capture of fortified positions, and on the other, their long-term consequences in perception, law, policy, and collective memory. These devices, from the experimental stage to mass production, were not merely a technical solution to a military problem. They were also catalysts for debates about the boundary between effectiveness and ethics in modern warfare. In terms of sources and research, arguments supporting the tactical effectiveness of flamethrower tanks draw on a wide range of materials: Pentagon and Marine Corps unit reports and operational diaries, post-war accounts from crews and commanders, medical records and casualty statistics, and interviews with witnesses, both American and Japanese veterans. These sources present a consistent picture at the tactical level. In terrain where deep fortifications and complex tunnel systems existed, mechanized flame reduced pressure on infantry, shortened the time needed to secure positions, and, according to many wartime commanders, saved the lives of attacking troops. However, when analyzing the absolute figures, such as numbers of dead, fuel consumed, or lives saved, researchers note discrepancies between unit reports, strategic estimates, and post-war analyses. These differences stem from recording methods, reporting objectives, and combat conditions, meaning wartime data was not always precise or comprehensive. In scholarship, two main lines of debate have emerged. The first emphasizes tactical effectiveness and concludes that this technique was a prime example of wartime innovation. When faced with entrenched defenses, technology and organizational creativity could shift the survival odds for attackers. Historians in this school often cite evidence from Iwo Jima and Okinawa, where mechanized flame was integrated with artillery, air power, and logistical pressure to overcome Japanese defenses. The second line focuses on humanitarian and ethical consequences, stressing the suffering caused by burning, environmental damage, and effects on civilians, even though in many cases the primary victims were soldiers sheltering in fortifications. From this perspective, while the weapon may have reduced casualties for attackers, it imposed long-term moral costs, shaping international relations, the laws of war, and social memory. These debates were not confined to academia, but existed within the military and government themselves. After the war, as nations reflected on campaigns and their consequences, a dialogue emerged between military necessity and the growing public concern for civilian suffering and the painful methods of warfare. This was one of the reasons why the use of napalm in later conflicts, especially in Vietnam, became a political flashpoint, leading to restrictions, adjustments, and ultimately influencing the research, procurement, and deployment of similar systems. In terms of international law, the post-war period witnessed the development of legal frameworks regulating wartime conduct, particularly focusing on civilian protection and limiting weapons that cause widespread destruction or unnecessary suffering. Although there was no blanket ban on all incendiary weapons immediately after 1945, growing awareness and social reaction led to conventions, declarations, and practices that made states more cautious when considering the large-scale use of incendiary systems, especially when civilians or the environment were at risk. The psychological legacy of deploying flamethrower tanks formed another crucial dimension. Crews and operators reported trauma, stress disorders, and lifelong haunting memories of witnessing victims burn. While many justified their actions by noting that they saved comrades' lives, feelings of guilt and haunting persisted. These stories enrich our understanding of the unseen costs of war. Beyond material losses and manpower, there exists a spiritual debt carried by those who operated such weapons. From a technical and doctrinal perspective, the influence of flamethrower tanks extended for decades. Militaries drew lessons about integrating new technology into doctrine, the importance of specialized training, and the logistics required for operating a dedicated weapon system. At the same time, defensive methods evolved. Fortifications were designed with more exits, fire-resistant linings, closable ventilation systems, and repositioned layouts to reduce vulnerability. Yet many of these countermeasures only partly mitigated the effects of napalm. Its adhesive quality and high temperatures were difficult to overcome by simple means. In collective memory and culture, images of napalm and raging fire became contested symbols, both as strategic markers in military history and as evidence of the moral limits faced by modern societies. Among some veteran communities and families, flamethrower tanks are remembered as life-saving tools. For others, they stand as emblems of wartime horror. Commemoration and remembrance are therefore marked by tension between acknowledging military effectiveness and confronting the suffering the weapon inflicted.